Hello. In today's video, we are going to discuss very basic yet very important concept, which is concentration of solutions. So this concept is very basic, but still it is important for 11th standard as well as for 12th standard students. Now let's get into it. So basically, we will study the definition of concentration or what is the meaning of concentration of solutions, and then we will see the types of concentrations of solutions, or we can say the ways in which we can express the concentration terms of solutions. So what is basically concentration? We can say strength of a solution. So from concentration, we can say strength of a solution that we can determine. Then what is strength? So we can see the definition: amount of solute in a given volume of solution. In a given volume of solution. So this is the definition of concentration. So first of all, I would like to focus on some terms that is solute and solvent. There are two terms, solute and solvent. So before going into concentration part, we must know what is solute and solvent. So suppose I'm taking an example here. Suppose I have taken a container which is having water and I'm adding salt or sugar, anything. So here salt is present in lesser proportion. So I will call it as solute, and water is present in larger proportion. So I will call it as solvent. So basically the lesser proportion is of solute and larger proportion is of solvent. Also we can say solute gets dissolved into solvent and solvent dissolves the solute. So these are the basic definitions we can say, or basic terminologies that are important for understanding concentration term. Now, what is solution? So basically, solute and solvent all together forms any kind of solution. So we have studied solute and solvent. Now we will come to the actual concentration part. We already discussed the definition, that is amount of solute in a given volume of solution, or I can write it in this manner: amount of solute per unit volume of solution. Per unit volume of solution. This can be the definition of concentration or the general formula for concentration. Now we will discuss the four ways in which we can express the concentration term, or four types of concentration we can say. So the first, which is mass percent, we also called as weight percent. Second is mole fraction. Third is molarity. See the spelling here, it is molarity. And fourth is molality. So these are the four ways in which we can express concentration of solutions, or these are the four types of concentrations. We will see it one by one. So first, it was mass percent. So the formula for mass percent is very, very important. The formula is mass of solute divided by mass of solution into 100. So as the word suggests percent, we will multiply this ratio by 100. So we will get values in percentage. So here in numerator term, there is mass of solute, that is the lesser proportion that gets added into solvent, and in denominator there is solution, which is solute plus solvent, we get solution. So this is very important formula, where numerator says mass of solute and denominator says mass of solution in 200. So the unit for this mass percent will be percentage. So the value here will be in percentage. Second, which is mole fraction. Mole fraction. Now, the name itself suggests it is a fraction. It will be a fraction or it will be a ratio. Ratios of what or fraction of what? Fraction of moles. So we know the concept moles or mole concept or the number of moles. We know that. So basically we are going to discuss the fraction of moles. So for example, here I have taken a solution which is composed of A and B, A plus B. So solution called as A plus B, which means there are two components, A and B. One is solute and one is solvent. So basically what is mole fraction? If we have to calculate number of moles of A and number of moles of B in particular solution, this formula is very helpful. So to calculate this, if we have to calculate mole fraction of A, so this is the denomination for this is zeta of A. The formula is number of moles of A divided by total number of moles. So for example, if there is A and B in a solution, we can say number of A upon N of A plus N of B. That will be the total number of moles in case of X of A, that is mole fraction of A. And in case of XB, that is we have to calculate mole fraction of B. How we will calculate? Again, the formula is same, but in numerator we will take number of moles of B divide by, because we have to calculate mole fraction of B. So the number of moles of B divide by again total number of moles. So denominator part will be the same. So here it will be Na plus Nb in this case, and here also it will be Na plus Nb. Okay, and the numerator and the denominator is the same, that is number of moles only. This quantity is unitless quantity. There is no unit for mole fraction. Now we will move further. So we have completed two ways, that is one is mass percent and other is mole fraction. Now we will move to third, which is molarity. Molarity, which is denoted by capital M. Don't get confused here. Here it is R, molarity, and which is denoted by capital M. Now we will discuss the formula. This is also very important formula. Number of moles of solute divided by volume of solution. Volume of solution in liters. So numerator part is number of moles of solute and denominator we have volume of total solution in liters. So the unit will be moles per liter, or we can say write it in this manner, moles per liter. And also we know that liter is nothing but decimeter cube, so we will write moles per dm cube. Okay, or we can say moles dm cube. These are the ways to write units of molarity. Then we will discuss fourth, which is molality. Now here there is difference in the spelling and also the denotion. So for molality, it is small m. Now we will see the formula. Again, the numerator part is same. Number of moles of solute divided by mass of solvent in kg. The denominator part is different here, mass of solvent in kg, and also here it is solvent and here it is solute. In case of molarity, it was solute and it was solution. So see the differences very carefully. So again the unit will be moles, because in numerator there are number of moles and there is mass of solvent in kg, so mole upon kg. Okay, thank you.